This episode is brought to you by Amazon. Sometimes the most painful part of getting sick is the getting better part. Waiting on hold for an appointment, sitting in crowded waiting rooms, standing in line at the pharmacy, that's painful. Amazon One Medical and Amazon Pharmacy remove those painful parts of getting better with things like 24/7 virtual visits and prescriptions delivered to your door. Thanks to Amazon Pharmacy and Amazon One Medical, healthcare just got less painful.
You're listening to Carbon Removal Newsroom, a weekly show about current events in the world of carbon removal, from technology and innovation to policymaking and job growth. Brought to you by Nori, the carbon removal marketplace.
Hello, everybody, and welcome to our science edition for October 7th, 2022. It has been a while, so really happy to be back and talking about the science of carbon removal. With us, as always, is Dr. Jane Zelikova, Executive Director of the Soil Carbon Solution Center and Joint Faculty in Crop and Soil Science at Colorado State University. Hi, Jane.
Hey, it's nice to be back. It's been a minute.
Today, we are joined for the first time as a regular co-host, but a former guest, Dr. Shannon Valley. And she has been a researcher of paleoceanography and marine biogeochemistry, has served on Joe Biden's National Transition Team, and is currently a AAAS Science and Technology Policy Fellow at USAID, or the U.S. Agency for International Development. So Shannon, thank you so much for joining us.
Glad to be here. Good to see you all again.
And then finally, this is Radhika Mulgafkar, as always, the head of supply and methodology at Nori. So today, as always, we're going to talk about the science of carbon removal, but in a way that we haven't in the past. It's going to be kind of talking about rewilding in a form. Rewilding is a form of conservation biology that includes reintroducing key species to return ecosystems to the way they were before human disturbances. There has been a lot of interest in this, but one of the more interesting pieces from my perspective is the fact that many people think that rewilding actually can play a role in carbon dioxide removal, and it has even been the focus of some National Academy of Sciences work. So with that, I'm going to start with Shannon, who is our expert in this space, to kind of describe the National Academy of Sciences 2022 Ocean CDR report, then what it was covered, and the emphasis particularly in chapter 6. So Shannon.
Yeah, sure. So first of all, I am not an expert in this, but it piqued my interest because I kind of have worked in adjacent fields. I really was curious about this chapter because it is kind of a real marine biology perspective that, and talking a lot about megafauna that I normally like to look at and go to the aquarium and see, but I don't really study in my day-to-day science. But yeah, so this report, it covers a variety of ocean CDR strategies. So for everything from ion fertilization to artificial upwelling, alkalinity enhancement, and to your more like engineered carbon sequestration solutions. And so for each of those, they provide an overview of current knowledge, efficacy, scalability, and the research needed on those different solutions. But I mean, I think that's been covered in an earlier podcast, actually. But for this specific chapter, this one is talking about the recovery of marine ecosystems. And so what this doesn't cover is traditional kind of blue carbon, which is usually thought of as kind of coastal ecosystems preservation and restoration. And that's usually like seagrasses, salt marshes, and mangroves. And those are like plant systems where your carbon is stored in those vascular rooted plants and then kept sequestered in the soil. And that was covered in an earlier NASM report. And this also is not really talking about kind of seaweed cultivation that in areas where they wouldn't naturally exist or wouldn't historically have existed. And that's in a different chapter of this report. So this one is really getting into carbon that gets stored in the deep ocean from the biomass of organisms, from jellies to sharks and their detritus or poop and so on.
So Jane, maybe you can describe a little bit more about some of the major forms of ocean carbon covered in that chapter?
Yeah. So the chapter really focuses on, and it uses a term that I really love, which is ecosystem-based solutions rather than natural or nature-based solutions. And I think that's going to be a term that I'm personally going to start using more. It's more inclusive of lots of different kinds of ecosystems. It sort of moves away from a value-laden term like natural. So I think I just really like that that's a term that they use really strongly throughout. And then the kinds of things that are included in ecosystem-based climate solutions or ecosystem restoration include things like phytoplankton, that's all of your sort of photosynthetic type of organisms and things that feed on photosynthetic organisms. Then you have your trophic cascade carbon, so things where an animal eats another animal and the carbon is moving through different, like through the food web and different trophic levels. And then you have sort of the transfer of nutrients between different layers within the ocean. And then you have biomass carbon, and that's carbon that's in the biomass of various animals that are in the ocean. So that's whales and jellyfish and sharks and dolphins and other things. And I have to also agree with Shannon. I'm also not an ocean expert, but love looking at ocean animals and learning about them. And then the major part that I think is especially relevant for this long-term sequestration piece is sort of the deadfall carbon, or carbon that is detritus and sort of dead animal biomass. And that gets deposited in various parts of the ocean, and including in the ocean floor, where it's sort of stored away from further decomposition because of sort of how the ocean system works. So those are the major parts of the biomass or the CDR pathways that are part of ecosystem recovery as a climate solution.
So I think all three of us are in agreement, right? Like these big ocean marine mammals in particular, for me, are always interesting and intriguing. And obviously or maybe not obviously, but I've never thought of them as a CDR mechanism. But they're also endangered, many of them. So what does this report kind of speak to about how you restore these animal populations, and what is the ability of the human species to kind of do what we need to do to help these populations rebound?
So one thing that the report, and especially this chapter, is really good about is giving some estimates from the published literature, and then very clearly stating that the published literature is not extensive. And these estimates are not very well constrained in terms of like published studies or even observational studies that are large enough to really explain the diversity that is our oceans. But there's an estimate that's cited in the report that's putting sort of marine animals comprising about 1.4 gigatons of carbon just in the animal biomass itself. And then in terms of how much carbon can be sequestered in addition to that, they're putting the estimate at somewhere in the range of 5% of our annual emissions. So that's kind of the capacity of additional CDR on top of what the ocean already does, which the ocean is already the oceans, plural, already take up a lot of carbon and are a really large part of how we balance the carbon equation globally. And so this is in addition to what the ocean is already taking up.
So Jane, just as a follow-up question, could you tell, is that based on like current populations of marine animals, or is that based on the best case scenario or worst case scenario in terms of extinction and other things that that are at risk for some of these marine mammals? I'm thinking particularly like of orcas here in Puget Sound, high risk of becoming endangered. So did they talk about what range of actual animals they use in these studies?
They give a pretty optimistic estimate that the ocean it's already a sink of about 25 to 30% of the CO2 that's emitted. And so in order for this to actually continue to work as we would like for it to, it requires the restoration of not just certain species, but also the the sort of interactions between species and the food web relationships, because ultimately the sequestration part requires this carbon to enter the sedimentary layers of the ocean and sort of sink below the surface layer. And for that to happen, it really needs to go through the food web. It doesn't just sort of go on its own. Although I have seen some people propose various biomass burial CDR solutions that may or may not be very scalable. And so this, it is a best case scenario, assuming that so many different interconnected parts in several oceans across the globe would be able to be restored in ways that restore the actual food web. Shannon, what do you think?
Yeah, that's interesting to think about it too. And I haven't thought about this previously, like through the different trophic chains, because also one of the things that they were talking about is even just like with certain species, part of their carcasses actually may increase the nutrients that then can stimulate other species production, which then could increase carbon sequestration. And it's all connected, and it's very obviously difficult to quantify. But I think that they did seem to kind of, there are papers and studies that have looked at different species and their own individual potential contributions. But some of that coverage is patchy, it seems like, and there's a lot of research to be done, of course, on the interconnectedness of it all.
I feel like that's a theme of oceans generally, that there's a lot of research and a lot of unknowns. And so really the call to action is to fund the research and get it started. But as Jane also mentioned earlier, that the ocean is one of the largest sinks of carbon dioxide, but it must be impacted, I would think, particularly the ecosystems within it as the planet warms. So Shannon, what does happen to ocean ecosystem as the planet warms, and is there an impact on the amount of carbon dioxide that it can that can be drawn down?
Yeah, so from a first order level, of course, there's always the solubility issue. So, right, like a warmer ocean is going to store less gas in the same way that a warm Coke will go flat faster. Like, can you tell that I did grad school in Atlanta? But so so that's already going to diminish the ocean's capacity to store atmospheric CO2. But obviously, oxygen is also a gas. And so if you there's different physical mixing processes in the ocean, and there's biology uses up oxygen in the ocean. So there's different physical mixing processes that affect how much oxygen there is in any given spot in the ocean. And then there's biology that consumes this oxygen as well. And so there's already zones, oxygen minimum zones across the ocean where oxygen is low, and climate change and warming is expanding some of these zones. And so as the ocean warms, you're going to have marine ecosystems that are going to be threatened by the decreasing levels of oxygen available to them. And so as we already discussed, with all of these different complex interplays, not only between the biology, the nutrient availability, and but also the ocean circulation piece, all of those complex interactions up and down the food chain. So planning for the ecosystem conservation and recovery, not to mention how you measure carbon removal while the ocean itself is changing and warming, that's going to be really complicated.
So I'm going to ask both of you this question. I'll start with you, Shannon. So what is the actual practice of habitat restoration done for CDR? Is it you leave parts of the ocean alone, or do we need to focus on interventions? Is it some combination of both? What is your opinion on that, since we haven't studied it really?
Yeah, so definitely marine protected areas are something that has been discussed extensively. It's in the paper. There's been this 30 for 30, 30% of area on land, and also talked about in the oceans by 2030 preserved to preserve marine biodiversity. Those efforts to conserve leave things alone for sure, including preserving the seafloor against disruption from mining and other kind of disruptive things at the benthic ecosystem level that can disrupt the ecosystems there, and can also disrupt the actual ocean seafloor and the storage of carbon there. But beyond the conservation, there's talk of reseeding of native algae. So again, not talking about transporting algae where it wasn't growing to a new place, but understanding what was there may have been degraded by human action, and then re-stimulating that growth. Changing fishing practices, that's important to consider as we balance carbon removal goals versus biodiversity goals and food needs, for example. And I think that this is also an area where probably indigenous and local knowledge of sustainable fishing practices can really lead us.
The report actually makes a really clear statement about that, as they sort of put together some guiding principles for how to scale ecosystem restoration climate solutions, especially ocean-based ones. And so they talk about the fact that ecosystem-based solutions are not a replacement for rapidly decreasing fossil fuel emissions, and sort of are not an excuse to delay any kind of action in decarbonization spaces. Ecosystem-based solutions include the protection, restoration, and management of lots of different natural and semi-natural ecosystems, and that includes land and the sea. And I think that's important because, like, in the topics of nature-based solutions, I work in agriculture, and some people may say, is agriculture a natural system? But I think it's a system that is functioning in the environment, and it is an ecosystem even if it's a constructed one. So I think including ecosystems that are constructed and highly engineered is still really important. Just like there are many marine ecosystems where we do like heavy fisheries, and those are fairly constructed ecosystems that could also be part of a climate solution. They also want to make sure that ecosystem-based solutions are created, employed, managed, and monitored in collaboration with indigenous peoples and local communities. And that's a really key thing in recognizing what Shannon just said, which is that often indigenous communities are managing these systems in a lot more sustainable ways, and we can look to them for guidance. And what's really cool about these ecosystems-based solutions is they also need to focus on enhancing biodiversity across all levels. And if they're not achieving that goal, then they're probably not going to be achieving other goals, including sort of sustainable carbon management. Because you can sort of imagine that you could like fertilize something or create a monoculture that would be really optimizing for carbon removal, but sort of not optimizing for any other ecosystem outcomes. And so they're saying like one of the guiding principles here is that we need to be optimizing for broader functionality. And that's what's so cool about thinking about the large mammals and large sort of like vertebrates in these systems, is that they are kind of an almost integrative tool to help think about more than just carbon drawdown specifically, because like when you restore large vertebrates, be it herbivores and terrestrial systems, et cetera, you're restoring a broader ecosystem function with lots of like sort of down cascading trophic effects that you can't engineer specifically without restoring a major vertebrate species.
Well, Jane, you led us beautifully into our next topic, because we're going to be talking about quote unquote negative emission whales, which obviously is pretty interesting, at least in my mind. Whales that are negative emission, who thought about it? Obviously, some authors did and scientists did. So in 2019, Alex Trembath and Wang at the Breakthrough Institute wrote an article about the concept of negative emission whales in response to an IMF report that large whales populations would draw down significant amounts of carbon dioxide. Trembath and Wang balked at this report and cited other, less ambitious figures assessed by other research. They also focus on the limited ability of existing methods to quantify whale CDR potential. Yeah, I mean, I think that's an issue across the CDR industry, quantification, but another topic for another day. So Shannon, I want to start with you, which is, do you agree with the authors that our current measurement techniques do not provide enough confidence to rely on habitat restoration for carbon dioxide storage specifically?
Yeah, that's definitely also, to go back to the previous report, an area where the national academies recognize that there's a lot of research and work to be done for sure. And again, it goes back to trying to get at the net effect of carbon sequestration from like a systems change, like making a change that may be targeted towards the restoration of one species, for example, and understanding what the net systems change is out of that. And that is something that we're still, as a research community, definitely working on. And I think the other thing is just even the monitoring component of that. Anytime that you do anything in the open ocean or the deep ocean, they're intrinsically remote, right? And so there are deep ocean monitoring systems. For example, in these marine protected areas, there are devices and cabling systems that go out there, that's floats and all that kind of stuff to measure what's going on in these different ecosystems. But all that's not cheap. And especially for the deployment of those kind of things, anytime you take out a ship to sea, it is not cheap. And so there's a lot of work to be done to get better at quantifying that to boost our confidence in the actual removal that's going on. But of course, that doesn't mean like this ecosystems recovery strategy, like blue carbon or other nature-based solutions, or whatever your preferred terminology for that is, just because we can't quite quantify the net CO2 or CO2 equivalent removed yet, it doesn't mean that there aren't really great reasons to conserve ocean areas and so on, and do all these other things that provide us so many other benefits, including the benefit of just nature for nature's sake, preserving our biodiversity and our ecosystems for their own intrinsic value, right? So, but we should continue to work on this. Our scientists should. I don't do this science, and let the research guide us on what we can eventually quantify.
Well, plus one to what you said about, nature for nature's sake. I completely agree with that. And one question as a follow-up, when you think about, and I ask a lot of people this question, but when you think about the urgency of the problem versus the time of science to come to answers, how do you reconcile that in your head and keep it moving when it seems like 2030 and 2050 are so quickly approaching, but the science takes so long? Shannon, I'm going to start with you, but Jane, I'd love your thoughts too, both of you obviously being academics.
The urgency of the problem, I feel that really deeply. And there's a lot we can do now without having every aspect of the scientific process fully resolved. But I think for us to really move forward with things in a no regrets way, we still need to quantify. That doesn't mean that we don't start sort of focusing on whale protection or coastal ecosystem protections and restorations. We do that because there are so many other co-benefits to doing that work. And we know there'll be climate benefits as well. But, and I say this in every episode, whenever we place that work into an offset or a carbon credit kind of context, all of a sudden it becomes really important to monitor and sort of verify the benefits very, very rigorously. And so protecting marine ecosystems, yes, we should do that. Protecting and restoring whale populations, yes, we should do that. I was talking to David Ho actually, and we were talking about this whole whale CDR thing. And I said, I'm pro whales. I'm just not pro whale CDR. Because I think one of the things we do when we start calling something a technology is that we commoditize something that maybe doesn't need to be commoditized. And we focus on the sort of the delivery of services that it can provide to us rather than the intrinsic value that it can bring to ecosystems more generally. So, I would say be really careful about proceeding with caution. But there are things like this that are no regrets, like restoring coastal and marine ecosystems that we can proceed with today, yesterday, and tomorrow, and they will have obvious climate benefits. I put the slide up. I gave a lecture in class yesterday, and I was talking about regenerative agriculture. And then I put the slide up after a friend of mine said this: anything that makes regenerative practices more profitable, easier, and socially acceptable will lead to climate positive outcomes. So anything that we can do to sort of get ecosystems restored and get like sort of more sustainable and more conservation into ecosystems in general, I think will lead to climate positive outcomes, and we just need to monitor them as we go along.
Yeah, amen, amen, amen. I don't think I can top any of that. Just to add that, yeah, I think the first guiding principle is to just first make sure that you're doing no harm. And this is a very like low risk approach in general. So good to go on that one. But I think besides the quantification part, it's also I think the next, I would imagine the next step is just to better understand, again, kind of the downstream trophic effects and interactions a little bit better, just to make sure that what we think is low risk is really that.
So I think from what you both have said, you would probably agree with the statement that maybe this idea of rewilding is not best in a CDR portfolio, but it's really about thinking about traditional conservation channels that allow this rewilding to happen outside of this carbon removal industry. Would you both agree with that statement?
100% would agree with that statement. I think the issue that lots of conservation organizations are running into is how to finance that work. As we continue the business of being humans that destroy our environment, there is more and more restoration and conservation that needs to take place. And lots of people are looking to carbon and climate finance as a way to sort of finance this conservation projects. So we need to have a really, difficult conversation about how to disentangle these conservation benefits, which are real and bring some climate benefits, from the financing mechanisms that are being deployed to essentially make sure conservation happens.
And Shannon, do you agree with the statement? Yeah, go ahead.
Yeah, I guess so. I mean, from what I've heard, I've also heard some say that this is an area of investment that's maybe better. These types of projects are better suited for the philanthropic community rather than traditional kind of climate financier communities. Although I think, as Jane was saying, there is being more thought that's put into different kind of creative climate financial solutions for these types of projects, and also more thought into kind of how could you kind of, I sound almost dirty saying it, but kind of commodify ecosystem services and so on. So I think there is kind of a nuanced place for a better kind of holistic understanding of what our ecosystems do for us. Also this intrinsic value thing, right? But yeah, this isn't for like the quick make a quick buck carbon folks. But if there is this holistic thinking that's beyond just kind of hacking our ecosystems, but really looking at how they serve us as they are, there's a space for that in the carbon market system. And I think too, when you're talking about kind of the international landscapes, and you're talking about then how do you kind of commodify this in the sense of how does this contribute to, nationally determined contributions and so on. This is also, I think the NASM report was talking about this being a place where, for example, small ocean nations that may have, small land areas, but very large EEZs in their surrounding oceans, exclusive economic zones, that contribution from them can also be part of their backyards. But again, that's where we need to better understand and be able to quantify the carbon sequestration benefits, so that could be used in that way.
I also, I think I've talked about this before, but I keep going back to sort of what we expect corporate actors to do in a space, and like how do we expect them to earn their right to do business with us, the general public, and that most of these corporate actors don't have requirements about their emissions, reporting them or mitigating them today, and that may change, and I hope that it does, because I think regulatory action is really powerful. But right now, especially in the voluntary space, the focus on carbon is just one way to do it. But there, if you think about somebody's sort of sustainability or climate budget, you could think about splitting it into conservation-based activities and carbon mitigation-based activities, and expect corporates to sort of fund and report on both. Since they're not being held to account on either factor right now, you may sort of, we as a public could demand that we see some activities that are focused specifically on conservation, because we know that that's important and that has some climate benefits that aren't focused on carbon accounting. So we have created the system. We're the ones that can change it, and we can change it in a way that helps fund conservation work in a different way without focusing on carbon.
The only thing I would have to add is that I was promised that we could talk about otters, sea otters.
Oh, well, what do you want to
They
say
haven't
about
come
sea
up
otters?
yet. I mean, that's that I love them. I mean, they did get a little shout out in the report. It was described as like sea otters being the quote unquote classic sea otters, of a way of by making sure that sea otters are that they are what do you call it? They're preserved as a species, right? They're in their habitats, that if they their presence kind of mitigates the growth of like echinoderms and other creatures that can degrade kelp. So by preserving the sea otters, then you preserve the kelp, and then you have like a net kind of carbon benefit out of that. And I just had to say that because I love sea otters. I'm pretty basic in that way. They look like, marine teddy bears, and they hold hands. And I've heard some bad things about some sea otters and, some of their behavior, particularly towards the female and the youth sea otters.
Let's leave that out of this podcast. This is a family-friendly affair.
I'm just saying, I don't want to hear any hate back on that, because # not all sea otters,
not all like sea otters,
not all of them. I choose to remember them greatly and fondly, and think of them as they're floating and holding each other and holding their pups and so on. So yeah, thank you for indulging me, since this is my first episode. I just really wanted to talk about sea otters.
I mean, Shannon, anytime you want to bring up sea otters, I'm sure our listening public would love to hear about it. I did not appreciate their role in CDR, but I do love actually the simplicity of that compared to most things we talk about. Like, they let the kelp grow is what I got from that conversation, which therefore carbon is removed, and they're cute and they love their pups and they hold hands. So, I would do another good news, but that's just sort of like such a nice way to end the show. So thank you both for your time. And Shannon, lovely to have you on full time. I look forward to many more interesting conversations.
Thanks so much for listening to Carbon Removal Newsroom. If you like the show, the best way you can help us is by giving us a great rating and review in Apple Podcasts, following the show on Spotify, and by sharing the show on social media. Tell your friends and help us spread the word about what's happening in the world of carbon removal.